Bismillahirrahmanirrahim. Sorry. Bismillahirrahmanirrahim. So the name of the course is statics. In Arabic, you call it statica, which is a part of engineering mechanics. In fact, in engineering mechanics, we have two courses. First is statics, and another is dynamics. So dynamics you will be studying inshallah in 202, and this is statics which we are studying in G201. In this lecture, we will describe the content of the course and also will give some introduction to what is statics. So these are the topics that we are going to cover inshallah in this course. In this lecture. So what are the objectives of this lecture? The first objective of this lecture is to explain what the statics is. It means what is the definition of the statics. And then inshallah we will provide an overview of the course content, and then also we will explain what we want to learn from this course. And in this lecture also we will revise Newton's 3 laws, because as you know, mechanics starts with the Newton's laws. And at the end of this lecture we will also revise US customary and SI units, because as you know, these two are the major units which are prevailing in the world. Of course, internationally we are asked to move to SI units, but still there are some countries which are stick with US customary units. So both the units we will discuss. Definitely in Saudi Arabia we follow SI units, so more detail I will be giving about SI units. Those who are studying first course with me, for them this is about myself. My name is Nadeem Siddiqui, and I am professor in the Department of Civil Engineering. I belong to country India, and civil engineering is my department. This is my office number 289. Okay. So if you want to meet me for some discussion, you can come to my office. Of course, in these Corona days, you have to take you have to inform me first that you are coming, so that I will be available at that time in my office. And this is my office telephone number, 4676962. You can call me for any genuine problem. And this is my email, nadeem@ksu.edu.sa. So of course, during this Corona period, this email is very important, because if you want any appointment with me or you want to discuss anything with me, you can write to me through this email, and inshallah I will give you the time, or I will clarify your query by this email. This is my website. We are not using this website for this course, because all the course related materials I will be putting on LMS. And as soon as the things become normal, inshallah I will put my office hour on my office wall, so you can see that office hours, and then you can come and visit me. So let us first define what statics is. So as I said, statics is a branch of mechanics. So first of all, we have to define what is mechanics. So mechanics is a branch of engineering in which we study the action of forces on material bodies in rest or in motion. It means mechanics basically deals with the effect of force on material bodies. That if there is a body and you apply force on it, what changes are going to take place in the body, or whether the body will move or not move. Okay? That is the subject of mechanics. Because as you know, when you apply force on a body, the force does some changes in the body. For example, if let's take this piece of paper. Okay. Now, if I apply force on this piece of paper in this manner, now this smooth piece of paper or this smooth sheet, now it has been converted into a deformed body. Okay, this has come into this shape because of the force, or even the force can be applied on it to tear it into two pieces. So now it has been teared, it is broken into two pieces. It has been teared into two pieces. This is also the effect of force on the material body. Okay. So in some bodies, even a small force you apply, you see the big changes. And in some other bodies, even if you apply big forces, you won't see much changes. For example, if you have a very big piece of stone, and even if you stand over it, even if you jump over it, even if you press from your both the hands, you will feel no change in that. So such bodies where we apply the forces and we see no changes, no deformation, yeah, no movement, yeah, or you can say no breaking, that bodies we call as rigid body. So rigid bodies are those bodies when you apply the forces on it, you will see almost no change, no deformation. Okay. On the other hand, there are some bodies when you apply the force on it, you see the changes, like in this body you have seen. Okay. So such bodies we call as deformable bodies or soft bodies. Correct? And truly speaking, ideally, no body is rigid, no body is soft, because it is the force that determines whether the body is a soft body or the rigid body. Because suppose even this piece of paper I take, okay, if an ant moves over it, or many ants apply force on it, you will see no change in that. So the force which an ant or ants are applying on a body, and you do not see the change in that. So for the forces of the ant, this body is a rigid body, because there is no deformation. Okay, there is no changes. On the other hand, if you have you say rigid body, a piece of stone, of course the force which you apply, you will see no change in the body. But suppose you bring an elephant, a heavy elephant, and then that elephant puts his leg on it, or it applies the forces through its leg, it might break. So for the force which an elephant is applying on the body, for that force this body is no more rigid. It is a deformable body because it deforms. Okay. So in mechanics, basically we study the effect of forces on the bodies. That when we apply the force on the body, what changes are going to take place in the body. Okay. And mechanics can be divided into two branches. First branch, first group is called statics, and another is called dynamics. In statics, forces acting on the body, but the forces are balanced. Or you can say body is in tawazun. Body is in equilibrium, because when the forces are balanced, we call the body is in equilibrium. Okay. Like here, this boy who is doing an exercise of gymnastics. Okay. This boy, sorry. The weight of the boy that will be acting through its navel, near navel, is acting down. Okay. and he's supported over the two handles, and these handles will offer reactions on him, on his hands, this way and on this way. So if his body weight is say 70 kilogram, in Newton it will be about 700 newtons. So this is 700 newtons. So can you tell me how much will be the two reactions, this and this? Yes, boys, how much will be these two reactions?
350, 350.
350, 350, very good. So this will be 350, and this will be also 350. So how did you calculate it? You calculated it based on the equilibrium, that because this body is not in is in equilibrium, so it means the total force acting down must be equal to the total force acting up, so that the net force will be zero. So this is the problem of statics. So in statics, forces are acting, but all these forces are balanced. All right? Like you have the bridges, you have the buildings. In the building, tremendous force is acting, but all the total force acting downward, it is balanced by the total reaction at the foundation level upward. So these two forces are balanced. In the bridges also, the total forces are balanced. Okay. So in statics, we study those bodies where the forces are acting, but these forces are balanced. On the other hand, in the case of dynamics, and generally in statics, body is not in motion, not in movement. Okay? It is not in motion in general. Okay. But here we are saying not in movement or movement in a relative sense. In an absolute sense, everything on the universe is in motion. Okay, because our Earth is in motion. So everything in the universe is in motion in an absolute sense. But in relative sense, that like this table, it is not in motion relative to me. Okay, because its position is not changing with time relative to me. So here I am, when I say it is not in motion, that means in a relative sense. Okay. In the dynamics, the bodies are in motion, in movement, with acceleration or without acceleration. When it is without acceleration, we call it with uniform velocity. And when it is without acceleration, that means the forces are balanced. For example, if you put your car on cruise and you move on a straight road, okay, so you are moving with a constant speed or velocity because you're moving in a straight line. I can say speed and velocity here are same. Okay. So that means the total force which is acting on your body, on your car, that is zero. It means the thrust which the engine is producing, that thrust is balanced by the wind drag and the friction which is between the tires and the road. So the total force is zero, and when F is zero, as you know, acceleration will be zero, change in velocity will be zero, and body will keep moving in a uniform velocity. So this is also a problem of dynamics where the body is in movement but with uniform velocity. And in this case, forces are balanced. On the other hand, you can have also the bodies in which the forces are not balanced. And when the forces are not balanced, then what will happen? As you know, for Newton's second law, each F produces the unbalanced force will produce the acceleration. It will change in velocity. So your body will move with non-uniform velocity. It will either the velocity will keep increasing or it will keep decreasing, or the directions of the bodies will keep changing. because as you know, the velocity is a vector quantity. When the direction is changing, then also your velocity is changing. So in dynamics, we are dealing with movement of bodies with uniform velocity or with non-uniform velocity. Okay. When it is a uniform, then of course the forces are balanced and total force is zero, no acceleration. But when the forces are not balanced, then there will be an acceleration and body will have the non-uniform velocity. Okay. But in this course, we are not dealing with dynamics. We are only studying the statics. Okay. So in the statics, your forces will be balanced, and body will be in equilibrium, and because of that, there will be no acceleration also. And using the principles of equilibrium, or later I will tell you about equations of equilibrium, we can solve a number of problems. Okay. For example, suppose this is a body, and here one force is acting, and here another force is acting, and there is a force here also. Okay. And suppose this is given to you 10 Newton, this is given to you 20 Newton, and here this is the force that you have to find out. Okay. So can you tell me what will be this F?
10.
F will be equal to 10 Newton. And how did you calculate? Basically, you have used the one of the principles of equilibrium, that the total horizontal forces must be equal to zero. So this 10 plus F minus 20 equals to zero, because it's statics problem. So from here, you have calculated F equals to 10 Newton. So this is a very, very simple problem. Of course, we are not going to solve such a very simple problem, but of course there will be some levels of problems. So here you have used one of the principles of, or one of the equations of equilibrium to solve this problem. So like that, there are thousands of engineering problems which can be solved with the help of various principles of equilibrium. So that things, inshallah, we will cover in detail when we go into the course. Okay. Okay, Mr. Muhammad, you have a question?
Yes, Doctor. So in this subject, we will always consider the body to be equilibrium.
Yes, always in the statics, always your body is in equilibrium. Means forces are acting there, but these forces are balanced. Because whenever there is an unbalanced force, this will become the problem of dynamics. Body will start having haraka, having motion, because unbalanced force will produce the acceleration. Acceleration will cause body to move. For example, if the body is at rest at zero velocity, if there is unbalanced force, it will move with some velocity. Okay, so in statics, your body is always and always in equilibrium, and forces are balanced. I hope I answered your question. Okay. Yes, Mr. Rashid.
Yeah, hello, doctor. Doctor,
Yes.
I want just to tell you that in the first 10 minutes, we are in another room.
Yeah, maybe,
Uh,
yeah, because I was
because
having a
we
problem with,
all of
yeah.
us come after 10 minutes. So that I will tell you that because the attendance.
No issue, because attendance I will take at the end of the class on my attendance register. So the LMS attendance I will not trust. Okay, I will
Okay,
take the
thank you.
attendance after at the end of the class on paper.
Okay, thank you.
Uh, Now I am coming to the contents of the course. What are the topics that we are going to cover in this course, inshallah? So as this is a branch of mechanics, so we will be spending a big time on forces, on force system. So around 6 weeks, we will spend only on analysis of forces, vector analysis, scalar analysis, finding out the moments, finding out the moment of the couples in two-dimensional problems and also in three-dimensional problems. Okay, so this will be our first and major topic, force system. This we will spend around 6 weeks of the semester just on this topic. And after that, after having the solid knowledge of forces and how to analyze forces, how to take the components of the forces, how to take the projections of the forces, etc., we will, and also how to find out the resultant of the forces. Okay, we will move to equilibrium of force system. Okay, so here we will study. Okay, Mr. Abdullah. Yes, please.
Yes, Dixon, good morning. How are you?
Good morning. Very good morning.
I wanted to ask about the slides. If are you going to send the slides on a weekly basis, or
It will be available in LMS, inshallah. I will
uh,
put it on LMS.
is it for the whole course or is it only each week?
Okay, I will put all the slides, no problem. I'll put all the slides.
Thank you.
At present, only one lecture will be present, which I have, which I'm taking now. But inshallah, I will try to put all the slides.
Thank you, Doctor. Have a nice day.
Okay, welcome.
You will
So,
send an email?
no, it will be available on LMS. All the slides, all the course-related materials, I will put in LMS. So from there you can download as is. Even the lecture recordings also I will put in LMS. Yes, Mr. Omar.
Hello, doctor. Is there
Yes.
any suggested problems or any problems that you recommend us to do as for studying?
I will explain you. Maybe no, if not in the next lecture, what will be how you will study, inshallah. I will
Inshallah.
I will tell you. Even in my lectures, you will see that I solve complete problems when I solve here. So, so lecture will be means quite complete. But I will tell you how to study to get maximum in this course. So after this, the third topic will be analysis of structures, plane trusses and frames. So plane trusses and frames are the types of structures that real structure that we are going to do in this course as the third topic. And after this, we will talk about the distributed force system. Actually, the forces are of two types. One type of forces which you know from your schools even that acts on one point. For example, here this force is acting over this point. Okay, so such force we call as point forces or the concentrated forces. On the other hand, there are some forces which do not act on the point, rather than they act over the length. For example, if this is a bag of cement, for example, you have put on the floor. So this force is not acting on a point, but rather it is acting over a certain length or certain region. So such force we call as distributed force. How to analyze such forces? That we are going to discuss, inshallah, in this article, distributed force system. After that, we will cover the two topics of mathematics. First is the centroid, and another is the area moments of inertia. Why we are taking these two topics of mathematics? The reason is that they are very important in mechanics, especially in statics. So, and also they will be required in the future courses, especially those who are in civil and mechanical engineering. For them, these two topics are very important. So that's why we are covering these two topics of mathematics in this course. And maybe you have studied these two topics somewhere in your mathematics course as well. So centroid and area moments of inertia. Yes, Mr. Omar?
So we are expected to know by the end of this course how the construction lifters work, how the equilibrium.
Yeah, inshallah, there is a one slide, course learning outcome. There I will discuss what we are expecting you to learn out from this course. So
Inshallah.
that will be, I think 1 or 2 slides it will come. After that, analysis of beams. Beam is also a real structural element, which is frequently used in civil and mechanical engineering for supporting the load and then transferring the load. Like in buildings, the load comes over the floors, and the floors are supported over the beams, and beams are supported over the columns, and columns are supported by the foundation. So primary load comes over the floor. From floor it transfers to the beams, and from beams it transfers to the columns, and then from columns it transfers to the foundation, and then from foundation it goes into the ground. So how to find out the forces inside the beams, that will be the topic of discussion here. And finally, we will also discuss the friction related problems or friction. As far as the friction is concerned, if you remember, in most of your physics courses, you ignore friction. You assume the body is frictionless, okay? And even in statics, many times we ignore friction. But sometimes we must have to consider friction. The reason is, in those situations, friction is the major force of equilibrium. Okay, so for example, if suppose this is an inclined plane and you are parking your car here. Sorry. So you see this car, this car will stand on the inclined plane and it will not roll back or not roll down due to gravity unless there is a sufficient friction between the car and surface to hold it on the inclined plane. So in this problem, if you ignore friction, you cannot justify its equilibrium, because this is the frictional force, which is the major force that is bringing this body in equilibrium. So many such in many such situations where the friction is a major force of equilibrium, we need to study it in a deep and separately. So that's why here we are covering this topic, that is the friction, because friction here is the major force of equilibrium. So these will be the topics that we are going to cover inshallah in this course. First, about 6 weeks we will spend over the force system. After that we will learn how to check the equilibrium or how to use the equilibrium principles to find out the unknown forces in the problems of statics. And then we will learn how to analyze plane trusses and frames, and also we'll learn how to handle distributed force system. And then we'll cover the two topics of mathematics, one is the centroid and other is the area moment of inertia. And then we will take an important structural element, beams, and we will learn how to find out the internal forces in the beams. And finally, we will discuss friction, especially for in those problems where the friction is the major force of equilibrium. So these are the topics that we will be covering, inshallah, in this course. And this is the textbook which you have to buy if you do not have. So the book is written by Miriam and Craig, and it is published by John Wiley and Sons. And frequently, in every 2 years, this book's new edition comes. So you have to buy the latest edition of this book, and make sure when you buy the latest edition, this is in SI version. Okay, because the original book is written in US custom unit, in 4-pound unit, and in the Saudi Arabia we follow SI units. So you have to buy that book only, which is written in SI unit, and you buy latest edition. But keep in mind, if you already have this book, okay, then there is no need to buy the book because of the edition, because as far as the old editions are concerned, they are also equally good, and you can use them because generally in these books they do not change the prime content of the book. They only change in the addition the problems, yeah, and solved examples. Sometimes they add some new solved examples, delete old solved examples, and add some new problems into the practice exercises. So if you have already book, no need of buying the new book for because of the edition. But if you are going to buy, then you buy the latest edition of this book. Okay. As far as the prerequisite of this course is concerned, there are only 2 math courses, 106 and 107, which are the prerequisite for this course. And prerequisite by topics, you must have basic knowledge of mathematics and physics, of course, and basic knowledge of calculus, especially integration. Actually, this topic only you require in those 2 topics of mathematics. That is the centroid and moment of inertia. Otherwise, in the rest of the course, you just need the simple knowledge, the basic knowledge of simple mathematics. Of course, you need the knowledge of trigonometry, because throughout the course, we will be calculating the angles with the help of given dimensions. So you must know how to calculate sine theta, cos theta, tan theta, cot theta, etc. with the help of given dimensions in the problem. There are various area properties like how to calculate the area of a circular section, how to calculate the area of rectangular section, triangular section, perimeters or circumference, etc. That also required primarily in the same 2 topics of mathematics. In the rest of the places, you don't need the knowledge much, but of course you need the knowledge of trigonometry and you need the knowledge of basic mathematics. Okay, this course learning outcome, inshallah, I will be covering in the next lecture because we have only 2 minutes. Yes, Mr. Abdullah.
Yes, Doctor. Where can I find the book?
You have to go to Bahu, underground, and there is a bookshop for the students. So there you can get the book with 50% discount, inshallah. Okay.